Okay, so in the last video or two, we derived this production possibilities frontier for Marshall. Given that he produces 1 song a day and 7 cars a day, he has a trade-off between songs and cars. Okay, and that trade-off was represented with this orange line, where on the orange line, he can produce any these are all the combinations of cars and songs that he can produce with his given budget of time, which was 1 week. So 1 song a day for 1 week, 7 cars a day for 1 week. He has to choose how to divide that week up. Okay, so if he only made songs that week, he can make 7 songs. If he only made cars that week, he can make 7 times 7, 49 cars. That's 7 cars per day for 7 days. Okay, and if he divided up the time, he can make anything in between. That's what this orange line represents. Okay, so this orange line we call the production possibilities frontier. So I'm going to show it kind of the way that I would like to see it when you do your homework. Okay, so this is a production possibilities frontier for Marshall, and I'm going to break down what everything means and how I'd like to see it when you're actually doing it for the quantitative assignment number 1. Okay, so first and foremost, you need to label the axes. The y-axis in this case will be cars. The x-axis will be songs. I mentioned prior that it's arbitrary whether you choose to do songs or cars on the x and the y-axis, except in as much as I will specify which I want, just for the sake of standardization. So in the Excel file, I had cars on the x-axis, songs on the y. So if you just flip this graph over, which I don't know if I can do, but if you were to flip this graph over, excuse my technological ineptitude, if you would flip this graph over, you'd have the same thing. Okay, it's just reverse. And both of them are equally valid. Both are fine. Okay. The next thing is I would like to see the intercepts of each graph, 49 and 7, or intercepts of the line with intercepts of the line, the x and y intercept. Otherwise, it can be kind of meaningless if you just draw a line. Notice in the graph on Excel, the intercept isn't clear. In the case of songs, it is, but in the case of cars, it's pretty close. So it'll be 49.0 if we scroll in, like if we hover over the point. But it looks like 50. I don't want that for homework. If you have a graph like this, just insert like a little text box. You can go to the insert button up here. You can insert text. And you can just add 49. Or you can add 0, 49 or something like that, just so that I know that you know what the intercept is. Otherwise, there's no real way for me to say, did you mean 50 or did you mean 49? Because they're different answers. So that's really all I need for production possibilities frontier. I want some line, the actual production possibilities frontier, the axes, and the intercepts. And that's all you need. And you can do it on the drawing toolbar with Microsoft Word if that's easier for you. You could do it in Excel like I did if that's what you find easiest. Just make sure you draw that line. It shouldn't just be points. You should have a connected line and make sure that the intercepts are clear. All right. So I had these little annotations here saying feasible and inefficient and infeasible, and then feasible and efficient. And when you're drawing the graph, unless I ask you what the feasible points are and what the inefficient points are or whatever, you don't need to label these out. This is just for your sake, so you can understand the point of a production possibilities frontier. Okay. So basically, what our exercise was doing is we mapped out how Marshall will spend his time, given that he spends all of his time making cars and songs, right? Now, it's not necessarily the case that if Marshall makes 0 cars, he's going to make 7 songs. Like, technically speaking, Marshall could not show up to work and make 0 cars and 0 songs. That's a technically feasible output. It's something that Marshall can do. That's all I mean by feasible. Something that he can do. Okay, so Marshall can be in this point. Okay, Marshall can make 0 cars, 0 songs. He can make 40 cars and 0 songs, whatever. Everything under this line is also a potential combination of things that Marshall can make. Okay, he can make 5 songs and 0 cars. He can make 5 songs and 1 car or something like that. Anything under this line. The red line, the production possibilities frontier, basically specifies if Marshall spent all of his time making cars and songs, what are the possible combinations? Okay, so necessarily everything above the red line is more than what Marshall can make, right? He can't make 8 songs because he makes 1 song a day for 7 days, tops. Okay, so 8 songs is above his production possibility. Okay, it's infeasible, you might say. It's something that he cannot do. He can't make 50 cars. He can't make 6 songs and 30 cars. Okay, everything above this line is infeasible. This whole area is infeasible. Something that Marshall cannot do, even if he spends all of his time making things, making cars and making songs. Okay. So under the line is everything that's feasible, and that includes on the line because he can make 7 songs, he can make 49 cars, and he can make combinations in between. So those are feasible on the line. Under the line is also feasible, and above the line is infeasible. Now, what do I mean by efficient? Efficient just means he can do more. Being efficient means he's doing the exact most that he can do, and everything that's under the line is inefficient. Okay, so he can make 5 songs. That's feasible to make 5 songs, 0 cars, but he has wasted resources. He's wasting time, presuming that he's not doing something that he also enjoys, which could be, production. But in this example, I specified that he can only make cars and songs. He's not doing a third option, right? So it's inefficient for him to make 5 songs and 0 cars because that gives him 2 extra days of inactivity. Okay, so it's inefficient even though it's feasible. So this point here, that would correspond to less than 7 songs and 0 cars, is inefficient because he has wasted resources. Okay, so the only efficient production patterns are the ones that appear directly on this line. Okay, the red line, the production possibilities frontier, are all the efficient combinations of cars and songs that Marshall can make. Okay, so all the efficient combinations that Marshall can make means feasible. So the PPF is everything that is both feasible, okay, able to do, that Marshall's able to do, and efficient in that there's no wasted time or wasted resource. Okay, so the PPF, in a nutshell, is a graph of all the feasible combinations of production patterns that Marshall can do, or the feasible and efficient ways to make cars and songs. Okay, and in general, you could say the production possibilities frontier is the efficient way to the feasible and efficient way to produce a given set of outputs. Okay. So everything above the line is infeasible. Everything below the line, excluding the line, is both feasible and efficient. And everything on the line is considered feasible and efficient. Okay. So below, feasible and inefficient. Above, infeasible. On the line is feasible and efficient. Okay. So just to recap, anything under and including the PPF is feasible for Marshall. Okay, it's a way that he can spend his time. He can make 7 songs and 0 cars. He can make 49 cars and 0 songs. He can make 3.5 songs and 24.5 cars. Okay, they're all feasible combinations. He can make 0 cars, 0 songs. That's feasible as well. Okay, but since he only has 2 options for how to spend his time, producing under the PPF is inefficient, leads to wasted days. So if he's making 0 cars and 0 songs, he has 7 days left over and that he's not doing anything. Okay, but if he's making 7 songs, he's spending all of his time, so that's considered efficient. Okay, he's not wasting any days. Okay, so the wasted days, the wasted resource, the wasted budget is what we consider inefficient. Okay. Notice that the PPF is downward sloping. Okay. What that's basically capturing is that there's a trade-off. Okay. At some point, if Marshall's making 49 cars, right, and he wants to make a song, what he has to do is he has to figure out what to do with his day, right? He has to basically cut down the number of cars that he wants to make in order to make a song. So there's a downward slope, there's a trade-off involved. And with economics, you'll see trade-offs a lot because it's impossible to just, continue producing without any sort of trade-off. Otherwise, there would be no conundrum. People would produce infinite, make infinite money, and there would be no field of economics because everything would be solved. But the trade-offs are what's really the heart of the problem. In an ideal world, he could just, continue producing indefinitely, but we don't live in an ideal world. So there's a trade-off between cars and songs. So if he makes 7 songs, he's making 0 cars. If he wants to make another car, he's got to give up some time in order to make the car. Okay, so he's giving up time making songs in order to give up the car. So if he wants a positive number of cars, he has to have less than 7 songs, even if he's producing both feasibly and efficiently. Okay, so as I noted, there's a trade-off between cars and songs, which leads to the downward slope in the graph. Now, what do you call that trade-off? I want you to think back to lecture 2 when we were discussing modeling, and in particular, when we were talking about having options and not doing one option. What do you call that? I expect you guys to be answering at home. So that's what you call opportunity cost. When you have 2 options or multiple options, in this case 2, you have 2 options and you're doing one thing and you're not doing the other, right? The opportunity cost is the utility from the thing that you're not doing, okay? So the downward slope between cars and songs captures the potential utility or the trade-off between, like, if I make 1 car, I'm not making 1/7 of a song. And if I make 1 song, I'm not making 7 cars. Okay, so that's what this downward sloping PPF is. The downward slope in the PPF is actually getting at, that there's an opportunity cost. There's a trade-off. Okay, there's a cost of doing something that you're not explicitly seeing. It's not an explicit cost the way that cars cost a day of time, right? 1 car might cost 1/7 of a day of time, and 1 song costs 1 day of time. That's the explicit cost. But there's also an opportunity cost. By not making a car, by making a car, you are not making 1/7 of a song. And by making 1 song, you are not making 7 cars. And they have a corresponding utility to that. Okay? So the slope of the PPF is actually capturing the opportunity cost in terms of the other good. Okay, so the opportunity cost of 1 car is the 1/7 of a song, right? So if you had cars on the x-axis, okay, the slope of this graph will be the trade-off between songs and cars 1/7. Okay, in this case, Songs is on the x-axis, so the trade-off is between songs and cars, and it'll be 7 cars for 1 song, okay? That is your opportunity cost. For every song that you're not making, you're losing for every song that you're making, you're losing 7 potential songs that weren't made. Okay, that's your slope, -7 here. Okay, so it's a downward slope picturing the trajectory of the opportunity cost, basically, the trade-off, the trajectory of the trade-off, which is your opportunity cost. And it's always in terms of whatever good is on the x-axis. So the opportunity cost of songs is -7, which is the slope of the graph. And the reason it corresponds to the x-axis good is basically because your slope is going to be y over x, right? Cars per song, right? And your opportunity cost is going to be quoted in terms of cars per song. For every song that you're not making, for every song that you're making, you are not making 7 cars, okay? So just to recap that all, there's a downward slope in the PPF, which captures the trade-off between cars and songs, or good 1 and good 2, or whatever you have as your, potential things that you could produce. Okay, that trade-off is going to be quoted in cars per song, right? As it's represented here, because song is the x-axis good. So the trade-off is 7 cars for every song. Rise, -7. Run, 1. -7 over 1 is your slope. Okay, so opportunity cost, trade-off, negative slope, they're all the same thing. They're all being pictured here in this graph. Okay, and likewise, if I had the other graph here, okay, with the reverse being the case where cars on the x-axis, right? The slope is capturing rise, right? Slope is defined as rise over run, or change in y over change in x. So your slope here is going to be your change in y, change in songs, the number of songs you're not making, for every car that you do make. So if I make 7 cars, right? I'm making if I make 7 cars, I can make 6 songs, right? If I want to make an additional 7 cars, I drop down 1 song. Drop down 1, run 6, okay? Run 7. So 1/7, right? Rise, run, rise, run. Okay, so your slope here is going to be 1/7. And likewise, your opportunity cost of cars is going to be 1/7. For every car that I make, I am losing 1/7 of the song. Okay, so if I make 7 cars, I'm losing 1 full song. 1 day that I spend making cars is 1 day that I'm not making songs. Okay, so the opportunity cost is pictured as the negative slope of the x-axis good, okay, in the PPF. I'm going to repeat that one more time because that was very succinctly put. The opportunity cost is pictured as the negative slope of the x-axis good in the PPF. Okay, so what is the opportunity cost of 1 song? 7 cars, right? So if we look at the slope, it'll be -7, right? 49 minus 0 divided by 0 minus 7. It's another way of doing it, change in y over change in x. So -7. All right, some other things about PPFs. Okay, so in the example that we gave with Marshall, the PPF is linear. Okay, so 49 over 7 is going to be a straight line here. But that's not always going to be the case. In fact, in upper level economics, it's rarely the case. And in your textbook, it's not going to be shown to be the case either, because your textbook isn't going to give you quantitative examples where it becomes more complicated to have curved slopes. Okay, so the PPF does not need to be linear. What does that depict? So if Marshall had a harder time writing songs as he writes more songs, so the first song comes to him like that. The second song, yeah, he's still got it. He's got some ideas stewing up, but the first song was easier to write. The second song, a little less easier. The third song, a little less easier. Okay. How would the graph change? So we call that diminishing marginal production, by the way. But if he has a harder time writing songs as he writes more songs, first of all, he's going to write less than 7 songs. We don't know the exact number because I didn't give a real, example here with numbers, so it's hard to find the exact number. But if he spends, on the linear example, 1 day per song, and then as it gets harder and harder to write songs, and he's got 7 days, he's going to write less than 7 songs. It might be 5 songs, it might be 4 songs, it might be 6 songs. We're not really sure. Okay. But notice here, the slope kind of curves down, right? We call this like a bow shape or concave. What this is basically saying is that as Marshall writes more songs, he takes a longer time to write them, right? So the first song might take a day, the second song might take a day and a quarter, the third song might take a day and a half, fourth song might take a day and 3 quarters, etc. And eventually you're going to peak at 7, right? You're going to reach a window where you can't write any more songs, so you've used up all your time. So if the first day takes 1 day, one day per song, in the first day you can write 1 song, and you're still making the same number of cars, you're going to have the same basic slope. It'll be slope -7 at the top. But then if it takes more days to write a song, your trade-off is going to be a little higher, right? So if you're taking 1.25 days to write the second song, that is 7 cars for the first day, and then 7 times a quarter cars for the second day, right? So you're slightly under, or you're slightly over 7 cars. It's whatever 7 times 1.25 is going to be the trade-off between cars and songs. So 1 song on the second day is going to take you 7 times 1.25 cars. So your opportunity cost is actually increased as you're writing more and more songs. Likewise, your slope is going to increase in absolute terms. So the negative slope is going to increase, or the trajectory at which you fall, the trade-off, is going to increase. Okay, so as you're writing more and more songs, the slope is getting steeper and steeper until on the last day, let's say it's day 5 and it takes you 2 days to write 1 song on day 5, what's your opportunity cost going to be? If it's taking you 2 days to write 1 song, that's 7 cars per day being missed each day. So 7 cars for the first day, 7 cars for the second day, 14 cars is going to be your opportunity cost for 1 song on the last day if it takes you 2 days to write that last song. Let me repeat that. So if it takes you 2 days to write the last song, because as you write more and more songs and you think of less and less, you have less and less to think about, so it's going to take you longer and longer. It takes you 2 days to write that last song. It will then take you 14 cars that you're missing out on because you wrote that last song. Your opportunity cost of cars per song has increased. And because of that, your slope, in absolute terms, your negative slope basically, has also increased. So your slope here on this last song will be -14. Okay? So it starts at -7, but as it gets harder and harder to write a song, your opportunity cost of writing a song increases because you're taking more time writing that song. And as your opportunity cost increases, your slope in absolute terms is going to increase. It's going to be steeper. Okay? Your trade-off is heavier and heavier. You're losing more cars per song.